welcome to another WJEC A level physics question. This is question 5 from June 2015's Unit 5, and it's a magnetic fields particle accelerator type question, which nowadays is found in Unit 4. For part A of the question, we've got a long thin solenoid with a current of 2.3 amps and 12,000 turns and a length of 1.8 meters. We've got to calculate the magnetic field strength in the center of the solenoid. Well, this equation is given to us in the data books. B equals mu naught Ni. Mu naught is 4 pi times 10 to the minus 7. N is the number of turns per unit length, so we would find that by taking the 12,000 turns and dividing it by the 1 meters of length, and the current is 2.3 amps. Now, as I've mentioned in previous videos, when you try to type in 4 pi times 10 to the minus 7, calculator doesn't like it, so a couple of ways around it. Do it as pi times 4 times 10 to the minus 7, or do 4 pi times and then the times 10 to the power button. If we put all those numbers into the calculator, we end up with 0.019 Tesla. For the second part of the question, we've got a cyclotron, one of the different types of particle accelerators, and we've got a uniform magnetic field, given the letter B, providing a centripetal force, while an electric field accelerates the charged particles as they cross between the D's here, and the resulting motion is a spiral as shown. Next part of the question, by equating the centripetal force to the magnetic force, we've got to show that the frequency of the AC supply is given by F equals BQ over 2 pi M. So centripetal force is either mv squared over r or m omega squared r. You can get to the solution either way. And the magnetic force on a charge of V is BQV. So we can cancel a V out. Now what we need to do next is we need to use the fact that V, the speed of the particles as it goes round in a circle, is 2 pi r over t. 2 pi r is the circumference of an orbit, and t is the time that it takes to complete one orbit. But we know that 1 over t is actually frequency, so that's how we get the frequency into this equation. So let's replace. So on the left hand side we got m times 2 pi rf over r equals bq. You can see that these r's will cancel, and then simply divide both sides by 2 pi and m, and we get to the solution required. For part 2, we've got to calculate the frequency, the cyclotron frequency that we just derived the formula for a carbon nucleus of charge 6e and mass 12 u's in a strong field of 3.3 Teslas. So we're just simply going to substitute numbers into the equation. 3.3 times charge is 6 lots of E, so 6 times 1.6 times 10 to the minus 19 coulombs, over 2 pi times 12U, where 1U is 1.66 times 10 to the minus 27 kilograms. Substituting those numbers into a calculator gives you an answer of about 25.3 megahertz. Or 25.3 times 10 to the 6 if you like. For the last part of the question, we've got to calculate the final speed of a carbon nucleus after it's completed 12 orbits of the cyclotron, and the potential difference between the D's is 14.5 kilovolts, and we're assuming that the carbon nucleus starts from rest. So the first thing we're going to do is we're going to calculate the gain of kinetic energy of our nucleus by multiplying 12 orbits by 2 places where the acceleration or the speeding up happens in the gaps between the D's, and each one of those gives 14.5 times 10 to the 3 electron volts worth of energy to a charge of 1 E, but here we have a charge of 6E. So if we put those into the calculator, we'll end up with about 2.09 mega electron volts. We're going to convert it into joules by multiplying by 1.6 times 10 to the minus 19, which gives us 3.34 times 10 to the minus 13 joules. And then finally we're going to use the kinetic energy formula. Half mv squared is the gain of kinetic energy, So V will be the square root of 2 times the gain of kinetic energy over the mass. So we have square root of 2 times 3.34 times 10 to the minus 13 over the mass of 12 U's again. Putting those answers into the calculator, gives us 5.79 times 10 to the 6 meters per second. Thank you very much for listening. Please remember to like and subscribe, and feel free to ask any questions. Goodbye.